Okay, again, section 3.6, and this is number 18 from the homework problems, and we have y equals 4 times the square root of the secant of x plus the tangent of x. So we want to take the derivative. So remember, the derivative of the square root of something is 1 over 2 times that something, and then if that something is the function, it's times the derivative of that something. So we're going to have to use that rule here. We have a constant 4 out front, so we can leave this 4 here, and then it's going to be 1 over, or 4 over in this case, 2 times the square root. And remember, this is my outside function, the square root of x. All right? And then I have to take the derivative of the inside function. So it's the derivative of the outside function, which is the square root of x. So the derivative of the square root of x, or the square root of u in this case, is 1 over 2 times the square root of u. This is my u, or my function, times the derivative of u, du dx, which in this case is the derivative of that. So I write it out. Okay, and then 2 divides into 4 twice, so this first part simplifies a little bit, so when I rewrite it, I have that. Then I've got to take the derivative of the secant tangent. The derivative of the secant is the secant tangent, plus the derivative of the tangent is the secant squared. Again, you have to know those formulas. All right, and then what I could do is I could factor out a secant and then move this over, so that's what I did. And then, so I wrote this as the secant, so I had the 2, and then I took the secant out, and I've got the tangent plus the secant. And I wrote this as basically to the first power, because what I did was I took this square root of the secant plus the tangent and wrote it as a secant plus a tangent to the 1/2. Now remember, by the commutative property of addition, these are the same. This is the same as this, just in different orders. So what I could do is I could take this power, and remember, when we're dividing, we just subtract the exponent. So this tangent plus the secant divided by the secant plus the tangent to the 1/2, I would just, they have the same base, so all I do is subtract the exponent. So 1 minus 1/2 is 1/2. So that's how I can write this. Oops, let's get the 1/2 over there. So there's my 2 secant of x, and then these top and bottom terms simplify to be just this top term, tangent plus the secant x to the 1/2. But the 1/2 is the same thing as the square root, so I could write it like this, and just kind of reverse the order to show you that these are basically the same. It can be in either order, doesn't matter. So 2 secant of x times the square root, that's the 1/2 power of the secant plus the tangent. Okay, so that wasn't too bad. And then number 20. And this is going to require just a little bit more work because of the chain rule. That's what we have. So we're just a little bit to the left there. There we go. Okay, so hopefully you can see all that. So we have y equals x divided by the square root of 1 plus x squared. So this won't be a problem with the chain rule. It's just a single factor. But here we've got a composite function. The square root is one function, and then 1 plus x squared is the other function. So I'm going to have, so my f of h would be the square root of x, and my g of h would be 1 plus x squared. Well, I'll apply the chain rule. So I'm going to use the quotient rule, so it's going to be low d high. So low is just this, the square root of 1 plus x squared, not taking the derivative of that. D high times the derivative of x, and the derivative of x is just 1, so I can just leave that. Less high d low, and this is where it gets a little more complicated. High times the derivative of the bottom. Now the derivative of the bottom will be the derivative of something squared, the square root of something. The derivative of the square root of something is 1 over 2 times the square root of that something. So it's going to be 1 over 2 times the square root of, and not x in this case, but 1 plus x squared. So because this is a function, I have to use the chain rule and take the derivative of that, so that's going to be the derivative of that. So there's my inside function. Again, I highlighted that in orange. So this is a rewrite, and then, over the denominator squared. Forgot that. So the square root of 1 plus x squared squared, and when I just square the square root, they just kind of undo each other, or it just becomes the square root of 1 plus x squared times the square root of 1 plus x squared, which is just that. So I don't need that exponent anymore, so that makes it a little bit easier. And then when I take the derivative of this using the chain rule, the derivative of 1 plus x squared is just 2x. So that goes there, and again, that's my inside. Everything else is a rewrite, and this is a rewrite. All I did was put the x up on the top, so those are the same. And this part here is just the 2x. Now what I can do is I can write everything in fractional exponents, and you'll see why in just a moment. So this is going to be 1 plus x squared to the 1/2 minus, and then the 2's cancel, or 2 over 2 is 1, I should say. And then x times x is x squared, and then I can bring this up as a negative 1/2. I can do that. All over 1 plus x squared. Okay, now we notice that we have two terms here separated by this negative sign. Okay, I could maybe highlight that negative sign in green so you see where it goes. But this is a negative sign here. That's this negative here. So I have these two terms. All right, two terms. And they both have a common binomial factor of 1 plus x squared. So I can factor that out. The thing is, I've got fractional exponents and then some negative, so I have to use least powers, and least powers tell me exactly what I factor out. This to the negative 1/2, that's what I factor out, the least power. So I wrote this in front, 1 plus x squared to the negative 1/2, and again we had this as a summer assignment, least powers. And then each of these terms, remember when we factor out, we divide. So I'm going to take this, and remember we subtract this. So this is exactly written the same way, 1 plus x squared to the 1/2, but since I'm going to factor out a negative 1/2, I subtract negative 1/2. Okay, minus x squared, that's the same thing, and this same thing again to the negative 1/2, so I write this out exactly as it appears, but I'm factoring out a 1/2, so I'm negative 1/2, I'm factoring out a negative 1/2 power, so minus negative 1/2. So this is the application of least powers. Remember, when we divide, we subtract the exponent, so that's what I'm doing there, and this is what I'm subtracting. Okay, and this is all over 1. So what I did, the next step was, since this was to the negative 1/2, I just moved this downstairs to kind of make it a little bit shorter, otherwise it's going to be kind of a long fraction. So if I move this downstairs to make this a positive 1/2, if I have 1/2 plus 1/2, 3/2, so that's how I get this. This comes down and combines with this to give me 3/2. 1 plus 1/2 is 3/2, because this changes signs when I move it to the denominator. What's negative 1? What's a negative times a negative? A positive. What's 1/2 plus 1/2? 1. So I've got 1 plus x squared to the first power minus x squared, and then that's, what's a negative times a negative is a positive. So what's negative 1/2 plus 1/2? That's 0. Okay, you can see how this is like tidying up quite nicely. This is fairly complicated. This is the kind of the raw form. Now we're going to get a more simplified form by using least powers. Now what's anything to the 0 power? That's just 1. So this is, and then anything to the first power is just what's inside here. So that's going to be 1 plus x squared minus x squared times 1. All over 1 plus x squared to the 3/2. But what's x squared minus x squared? That's 0. So that just leaves me with 1 plus 0, which is 1. So my numerator is just 1, and this is my denominator, and that's my final answer. I think this book actually put this up on the top and wrote it as 1 plus x squared to the negative 3/2, but this is just as well. This is fine. And that's 3/2 if you can't see that, I know. It's a little blurry there, so it's 1 over 1 plus x squared to the 3/2 power. That's the same. Okay? So that's kind of fun, and again, we get to use least powers now, so you see why we're doing that. Hope that helps.